Welcome to Diseases, Animals, and Robots, the epidemiology show. Sit back, enjoy the video, and let's explore the science of disease together. Today we're unpacking how rerouting trucks and boosting cleaning protocols could be game changers in stopping disease spread between farms.
Okay, think about your farm for a second. Every single day, you've got this constant stream of vehicles coming and going. Feed trucks, animal transport, crew vans, right? They're the absolute lifeblood of your operation. But what if they're also a kind of hidden highway, delivering costly pathogens right to your doorstep? It's a risk we really can't afford to ignore. And you know what? New data suggests there's a much smarter way to manage it.
So that brings us to the big question. Is one of your biggest threats actually arriving on wheels? As a farm manager, you spend so much time focusing on animal-to-animal contact, and for good reason. But the research we're going to dig into today suggests we need to look a little closer at what's happening in the parking lot. The good news is there's a smarter way to handle this. This isn't about stopping deliveries. That's impossible. It's about making them safer. This diagram here really shows the core idea perfectly. It's a system that acts like a super smart dispatcher, one that analyzes all the risks and then picks the safest, most efficient vehicle for every single job. So here's our game plan for this explainer. First, we're going to put a number on the threat that vehicles pose. Then we'll look at why a simple wash isn't always enough. After that, we'll unpack how a smart rerouting system actually works, check out the hard data on how effective it is, get real about the costs, and finally, frame the big decision for you as a manager. All right, let's start with just how big this problem is. We're going to put a real number on the risk that literally drives onto your farm every single day. 42%. Just let that sink in for a second. According to the research, that's how much vehicle movements can contribute to the spread of really devastating diseases, things like porcine epidemic diarrhea and African swine fever. We're not talking about a minor factor here. This is a massive vulnerability in our biosecurity chain. So here's the bottom line. Every single truck that comes and goes is a potential vector. These aren't just logistical movements anymore. They are biosecurity events. The same truck that drops off feed could have just left a farm that's positive for PRSV. And without the right protocols, that risk is carried right onto your property. Now, I know what you're probably thinking. Hey, we have wash stations. We clean and disinfect our vehicles. And that's absolutely a critical step. But let's take a look at why it might not be the silver bullet we all hope it is.
We rely so heavily on C&D, and we should, but is it completely foolproof? The data suggests we really need another layer of defense on top of it.
See, here's the challenge. These modeling studies show that even if C&D protocols were 100% effective, they just aren't applied 100% of the time. The reality of a busy operation is that not every vehicle gets a full, effective clean between every single stop. For example, the source data for this study showed only 5% of feed vehicles went through C&D between shipments. And that gap, well, that's where the risk lies.
Now this is where it gets really powerful. Check this out. This chart shows a scenario where cleaning was simulated to be completely ineffective. 0%. This smart rerouting system still cut the number of high-risk contacts from feed trucks by 45%. That proves that just by being smarter about which truck goes where, you can slash your risk, totally independent of your wash station.
So how does it actually do that? What's the secret sauce here? Let's pull back the curtain on the logic of this system. It's not magic, it's just really, really smart logistics. Okay, first, you gotta understand this key concept: network communities. Think of your farms and the vehicles that service them like neighborhoods in a city. Trucks tend to work within these specific groups of farms. So the system's main goal is to keep these neighborhoods as separate as possible, preventing a truck from one neighborhood from carrying a disease into a totally different one. This breaks down the decision-making process perfectly. For every single delivery request, the system runs through this checklist. First, it looks at a truck's 30-day travel history. Has it been to any farms that are positive for PRSV or PDV? Second, it checks if sending this truck would cross one of those neighborhood boundaries we just talked about. Third, it gives a big priority to any vehicle that's just been cleaned. And finally, of all the safe trucks left, it picks the one that can get the job done the fastest. It's a simple hierarchy: safety first, then efficiency. So that all sounds great in theory, right? But what does the data actually say? Let's get to the results and see how this thing actually builds a stronger biosecurity wall around your operation.
This quote from the research paper really sums it up. Even with zero CND effectiveness, the system cut contacts between infected and clean farms and slashed the interactions between those distinct farm neighborhoods by 17%. It proves the system works on its two main goals, stopping direct transmission and containing potential spread. It's like a 1-2 punch for biosecurity.
This chart shows the biggest win. Just look at the tall blue bar on the left. That represents the number of direct truck links from a known infected farm to a clean one in the real-world data. Now, look at the tiny bar next to it for the rerouted system. For feed trucks, even at just 50% CND effectiveness, the rerouted system had 92% fewer of these super high-risk contacts. You are essentially taking disease vectors right off the road. And here's that gatekeeper effect we talked about. This chart shows the number of times vehicles crossed between those network communities. With rerouting, you see this massive drop. In the best-case scenario with perfect cleaning, it practically eliminated cross-community travel, reducing it by 99.9%. That's how you contain an outbreak to a small, manageable zone, instead of letting it rip across your entire system. Okay, a system this effective must have a cost, right? There's no free lunch. To make a smart decision, you have to look at the operational trade-offs, and we're going to be realistic about them.
The biggest cost is going to be fuel and time. Because the system is prioritizing the safest truck, not necessarily the closest one, vehicles are going to travel more. In the simulation, rerouted feed trucks traveled up to 60% further. That's a serious increase in miles on the road, no doubt about it.
And second, get ready for this number, the system enforces best practices. In the simulation, rerouted feed vehicles made 20 times more visits to CND stations than they did in the real-world data. 20 times. That's a huge operational shift, and it comes with real costs for water, disinfectant, and labor. So let's just lay the price tag out on the table. You're looking at higher fuel bills and more driver hours. You've got way more frequent and costly CND events. Now, there is one potential upside. It does lead to a more balanced use of your entire fleet instead of overworking just a few trucks. But the primary trade-offs are real, measurable costs.
And all of this brings us to the final and most important part. As a manager, you're the one who has to weigh these factors and make the call.
And this really is the fundamental choice. On one side, you have the cost of rerouting. Yeah, they're higher, but they are predictable, operational expenses you can actually budget for. On the other side, you have the cost of doing nothing. And that is the unpredictable, potentially catastrophic risk of a major disease outbreak, something that can threaten the very existence of your business. So ultimately, it all comes down to this one question. When you look at your specific operation, your risk tolerance, and the potential financial devastation of a major outbreak, which cost is truly greater? That's the decision this data empowers you to make.
This is everything for today. If you are interested in learning more or have additional questions, I strongly encourage you to read the full publication. The reference is provided below. If you still have questions, feel free to contact the authors. Thank you for watching, and see you soon.